Last lesson I gave you an exam question. They all should have been marked for you now, giving you a score out of 4. I just want you to have a read of these 2 example answers and think, which one do you think is the best answer? So the question is, explain how 2 physical factors other than land use may increase the risk of flooding. So answer A, urbanisation can increase the risk of flooding as the impermeable concrete prevents infiltration, resulting in more overland flow and an increase in river discharge causing a flood. Deforestation also increases the flood risk as the lack of trees means less interception, resulting in more overland flow and an increase in river discharge causing a flood. Answer B. Very heavy rain can cause a flood because the rain is falling too quickly for it to soak into the ground. Steep slopes also mean that water cannot soak in, so it flows to the river very fast and makes it flood. So the best answer is actually answer B. It wouldn't achieve 4 marks, it'd probably get 3 out of 4 perhaps. Answer A actually doesn't pick up any marks, and the reason it doesn't get any marks is because it talks about changing land use, it talks about human factors, and the question specifically asks about physical factors. So urbanisation and deforestation are both human factors that increase the flood risk, whereas answer B, very heavy rain and steep slopes, they are both physical factors. What they don't do is they don't explain fully about how that increases the flood risk. The very heavy rain, it needs to say that it falls too quickly, so infiltration can't happen. This means overland flow occurs, water gets into the river more quickly, causing a flood. Same with the steep slopes. So that's why that is not a perfect answer. So we're now going to look at how we manage floods. We've looked at hydrographs, we've looked at causes of flooding, both human and physical. Now we're going to look how we manage those floods using both hard and soft engineering. So we've just got to evaluate which method would be the most effective in contrasting situations, so in different locations. Still on our final bubble, we'll look at these strategies. Then next lesson we'll look at how we manage flooding in the UK, looking at a named example, and we'll look at a place called Boscastle. So we're going to go through the costs and benefits of hard engineering and soft engineering. Your starting point is, I want you to do a little mind map, spider diagram, whatever you call it, and just write down everything you can think of. What can we do to prevent floods? But remember, we're doing rivers. Don't write down what we can do at the coast. Don't talk about sea level rise, anything like that. Talk about how we prevent flooding on rivers. So the ways that we can manage flooding on rivers is we've got our hard engineering, so that's our man-made structures that are used to prevent or control natural processes from taking place. They're usually very expensive, but good for protecting expensive property or land. It can have negative impacts on the environment, and it saves money by preventing flooding. You've then got your soft engineering. So this is when the management works with natural processes to manage the flood risk. It doesn't involve building artificial structures or stopping those natural processes, but it does aim to slow and reduce the movement of water. Soft engineering is usually cheaper, and it does have environmental benefits. So here you have some examples of what the different types of engineering are. I suggest you write down the definitions of both your hard engineering and your soft engineering. It's the same at the coast, same definitions. Hard engineering is man-made structures that stop natural processes. Soft engineering works with natural processes. So once you've got your definitions, we are going to go through a range of different strategies. You can either print or you can draw a copy of this table for your flood management. So you're going to write down the name of each strategy. We've got 8 in total. A brief description of what the strategy involves. What are the advantages of the strategy? So I want 2 advantages. I then want 2 disadvantages. Whether it's hard or if it's soft engineering. And then how effective you think each strategy is, and you can rank it between 1 and 8. So 1 is the most effective at stopping flooding, 8 is the least effective at stopping flooding. So print that table. I've attached the slides to show my homework, so you can download them if you like. And then at the end you need to justify which is the best strategy and why you think that. So the information, I've put it attached to show my homework as some information slides. You just need to download those, go through them, fill in your table. Once you've filled in your table, I'll give you the answers. So these are your hard engineering strategies. You've got dams and reservoirs. So basically building a big wall that holds back water, stores the water in a reservoir. They can then release the water in a controlled way. So the advantages, they can attract tourists, go sailing, fishing, that kind of thing. You can also use it to produce electricity. Disadvantages, they're very expensive. You're talking millions, sometimes billions of pounds. They can trap sediment so they can get full up. They can flood habitats, and they can actually flood settlements. So there's a reservoir up in the Peak District called Lady Bower, and that flooded a village. So when we have really dry weather, the level in the reservoir falls, and you can see the top of the buildings actually sticking out in the reservoir. Pretty cool, hey? Another hard engineering, you've got river straightening and dredging. So that's when you straighten a river. That means water can flow through it very, very quickly, and it means it doesn't flood the area. It's good because it means more water can be held in the channel, and it can be used to reduce the flood risk in built-up areas, so in the centre of towns, cities, that kind of thing. The disadvantage is, well, you need to dredge it frequently. You need to go along with a big digger on the back of a boat and dig out all the mud and all the sand that's collected at the bottom. And actually, because you speed up the flow of the river in the city, it actually causes a flood risk downstream, so it's not perfect. Another hard engineering, you've got embankments. So this is when you raise the side of the rivers, as you can see here, like a big wall. Got these in cities like London, even in some places in Nottingham. And that means the river can hold more water. So advantages, they're relatively cheap. You only have to pay for them to be built once, and it allows the water to be contained in the river. The disadvantages, well, it looks unnatural, and actually it can increase the flow of the water in the river, causing a flood downstream. So that's what happens at the River Trent. It flows through the centre of Nottingham more quickly, but then it's more likely to flood in places like Loudon and Gunthorpe, where they don't have these flood walls. You then got flood relief channels, and what they are, this is another hard engineering strategy. So that's when you build another channel, and that means you can take water out of the river to stop it flooding. So that's your advantage. It removes excess water from the river channel to reduce flooding. Disadvantages, they're expensive, and if the water level continues to rise, you can actually still get flooding take place. Now we've got our soft engineering strategies. So you've got flood warnings and preparation. So this is where the Environment Agency monitor the river. So they use things like those hydrographs that we did last time. So they monitor the water in the river, look at the weather forecast, and they issue warnings. So you'll see them on telly, in newspapers, on TV, get through to apps on your phone, and it just says to people, yellow, slight risk, amber, big risk, red, serious risk. Advantages, it means people have time to protect their properties, so you can have sandbags, and you can save your possessions. So you might move things from the ground floor of your house, lift things off the ground so that they don't get destroyed. The disadvantages, some people might not see them, they might not have a phone. Sometimes they happen too quickly, so people can't even prepare. And actually, it doesn't stop the flooding from happening. It just warns people so that they can reduce the impacts of it. You've then got floodplain zoning, so another soft engineering, and this is where they only allow the land to be used in certain ways in certain places. So near the river, it's things like cattle grazing or football pitches, things that don't easily get damaged, and your houses, your buildings are further away from the river so they don't flood. So the advantages, more expensive buildings and land uses are further away, and there's less damage caused. Disadvantages, well, you can't just change, you can't just demolish the centre of London and move it. And actually, planners have to decide what type of flood to plan for. So looking at where would actually get covered in water. Another soft engineering, you've got planting trees. So you plant the trees, they catch the rainfall, they intercept it, they take it in, they store it. This is good because it's relatively cheap, doesn't cost a lot, and it has environmental benefits. So it creates habitats for wildlife. Disadvantages, well, you plant trees and they take years to grow. So it doesn't have an immediate impact. And actually, it's very difficult to do in urbanised areas, so in towns and cities. You can't just rip up the concrete and plant trees. You've got river restoration. So this is when you return a river to its original route, where you put in place meanders and wetlands that actually slows down the flow of water and stores the water. So it's good because it prevents flooding downstream and it creates new habitats. So it's got environmental benefits, but it can increase the flood risk in some areas, especially where you're doing this. It will encourage a flood in that location. So you can't do it in the centre of towns and cities because they've got concrete everywhere. Okay, so that should be your table done. You should have filled in any things you're missing. Now let's have a look at this quick diagram and think, well, why are a range of flood management strategies used along a river? Why do we use more than one? Why do we use a mix of hard engineering and soft engineering? So have a read through, see what's done, where you've got your dams, your reservoirs, where you've got your land use zoning, where you've got your planting trees or your afforestation, where's your channel straightening, your embankments, etc., etc. And then we need to answer these questions. So explain why all of these different strategies are used in different places at the same time. And could anything else be done to reduce the flood risk? So the short answer is these strategies are used in different places at different times because one strategy is not suitable everywhere. You can't build a dam or a reservoir in the centre of a city. So you build your dam or your reservoir up in the hills, up in the mountains, away from those urbanised areas. You can't plant trees in the centre of a city, so you tend to do it up in the upper course of the river where it's more natural. And then where the value of the land is quite high and you can't use those soft engineering strategies, that's where you do things like your channel straightening, your embankments. So spend a lot of money to actually stop flooding taking place. And the most successful management actually does use a mix of hard and soft engineering to protect different places in different ways. So next time we'll look at our Boscastle case study